Now in section 5.1 we're going to look at parallelograms. Now a parallelogram is a quadrilateral. Remember, a quadrilateral is any closed, bounded, straight-sided figure. So if it's straight-sided, closed, four-sided, it's a quadrilateral. So these are quadrilaterals. A parallelogram is a quadrilateral with both pairs of opposite sides parallel. And that's something you want to copy down and put in your notes. So AB is parallel to DC, and AD is parallel to BC. Opposite sides are parallel. Now we're going to prove a few properties about parallelograms, about sides, angles, and diagonals. So first thing we're going to do is look at the opposite sides. So Theorem 5.1 says that when we have a parallelogram, opposite sides are congruent. So it would say that AB is congruent to CD, or AD and BC. Okay, so AD is congruent to BC and AB to CD. And that's what we're going to try to prove from the fact that opposite sides are parallel. So let's write this up. Statement, reason. Okay. Now we need to have our given. ABCD is a parallelogram. And I'll draw a little parallelogram ABCD, given. And then we know that okay, so we want to show opposite sides are congruent. We're going to do that using our triangle congruence theorems. We need to see how we can use our triangle congruence theorems to show opposite sides are congruent. So of course, there's no triangle here yet, so you know it's dependent upon you to see that you need to draw an auxiliary line. Because you got to remember, between 2 points, there's a line. So we could draw this line in here, call it an auxiliary line. And that's like a helping line, a line that helps you think about what you're doing in your diagram, in your proof. Okay, auxiliary. So, and then we see, hey, we got two triangles. We got one right here and one right here. And we know that this side is shared in common, so we know that we got a congruent side. And it's probably not going to be anything else. Remember, we've got, probably not any other side that we're going to use. We've got these and a few more that we could use, but we're not going to use anything with two sides in it because that's what we're trying to prove. We're trying to prove sides are congruent, so we cannot start with that. Then we'd be claiming what we're trying to prove, which is a fallacy of reasoning. It's very illogical. So we're probably going to use something like this. So we got to find some angles that are congruent. Let's see how we can do that. So we know that that is the same as that. So we've got two lines. If we ignore these for now, and that might be a good idea to erase it so you don't get confused as to what you can use and what you can't. This helps you zoom in on what you can actually use, this and nothing else. So these are parallel and that's your transversal, so that all that we could ever do is have a Z shape, so we know that this is congruent to that. Okay? And we'll draw others back in so we won't get confused. And then we'd know that since this one is parallel to this one, we're going to use those and erase this. So all we have is this right here. Hey, we have another z, so this is parallel or congruent to this by alternate interior angles. Okay? You have to make sure you do this right. I'll draw this back in. Okay, so we see that because of parallel lines, one is congruent to 2, and angle 3 is congruent to angle 4. So let's write that up. So angle 1 congruent to angle 2, angle 3 congruent to angle 4, because parallel lines means that alternate interior angles are congruent. Okay? And then what do we have there? Just like we thought, angle, side, angle. A pair of angles, a pair of sides, happens to be the same thing in this case, and another pair of angles. So remember, we got to write down everything we need. If we're going to use angle, side, angle, I've got a pair of angles, check. I've got a pair of angles, check. Do I have a side here? No. So I cannot use ASA yet. I must write down that BD is congruent to BD, identity, and now we can say that triangle, because we got the side, ABD is congruent to triangle, let's see, ABD, CDB, by the angle side angle theorem. And then, since the triangles are congruent, all their parts must be congruent. So AB is congruent to DC, and AD congruent to BC, CP, CTC. When triangles are congruent, the corresponding parts are congruent.